Assalamu alaikum. Welcome to my YouTube channel. Today I am going to talk about the rate of reactions or speed of reactions. So first let me tell you that some chemical reactions are very fast. Some reactions are very slow and some reactions are medium. For instance, the explosion of dynamite is an example of very fast reaction because the dynamite explodes within fraction of seconds, releasing a large amount of energy, sound and heat. That's why it's destructive. So this reaction, explosion of dynamite, takes place within milliseconds. So it is an example of fast reaction. Another type of reaction is very slow reaction. For example, fossil fuels. Fossil fuels, they are formed over thousands of years or maybe millions of years by very slow decomposition of certain microorganisms, etc. So the formation of the fossil fuel, it took place over millions of years. So this is example of slow reaction, very slow reaction. And some reactions are medium. For example, when we react together zinc and an acid, suppose hydrochloric acid, and hydrogen gas is produced. So this is a medium reaction. So the speed of reactions differ, it vary in various chemical reactions. As I mentioned that the speed of reaction, it varies. Some reactions are very fast, some are slow, some are medium. So now there is a need that we should measure the speed of the reaction and we should calculate and we can estimate that how the reaction is, either the reaction is proceeding in fast pace or in slow pace, what is the speed of the reaction, what is the pace of the reaction. Now for measuring the speed of reaction, there are different methods. One of the method is by measuring or by recording the loss in mass of the reaction mixture. Here with the help of the diagram I will explain. For example, this is the physical balance which is showing the reading, for instance at the moment 12.65 grams. So here in the reaction there is calcium carbonate and the acid is sulfuric acid. So when the calcium carbonate, we know it reacts with sulfuric acid, so the reaction starts and carbonate salts react with acids. So it will form calcium sulfate and it will form carbon dioxide gas in water. Now carbon dioxide gas which will be produced in this reaction, it will escape through this conical flask through the cotton plug, and the purpose of the cotton plug is that to avoid splashes to be lost in the environment. Therefore the loss in mass should be only linked and dedicated to the release of the gas, for example carbon dioxide gas. So in order to make our results accurate, the cotton plug is added or it is fixed here so that the loss in mass should be only due to the gas produced and released in the as a result of this chemical reaction. So and when the loss in mass will take place, so we will record this loss in mass with the help of stopwatch with equal interval of times. For example, after we can take the reading after every 30 seconds or after every 1 minute or after every 15 seconds. So and maybe the initial mass was 15 grams and then it reduced to over 30 seconds it reduced to 12.6 gram or 12.65 gram, then it reduced to 10 grams, then it reduced to 9, and then maybe it reduced after every 30 seconds it is decreasing, maybe 8 and then 7.5, and then at 7.5 it stopped. Now no further loss in mass is taking place in the further reactions. So in this way, after every 15 seconds suppose, or after every 30 seconds, we will record the loss in mass. So this is one method of measuring the speed of reaction. Another method of measuring the speed of reaction is by measuring the volume of collected gas, because in most of the chemical reactions some kind of gas is produced, for example carbon dioxide or hydrogen or ammonia or any other gas. So we can the second method is that we can collect the gas which is being produced as a result of this chemical reaction in the gas syringe, and once again in the gas syringe we will measure and we will record the volume of the gas collected with the help of stopwatch with equal intervals of time. For example, after every 15 seconds, or maybe after every 10 seconds, or maybe after every 1 minute, the reading will be taken, and in this way we can judge and we can estimate the speed of reaction. Other methods of measuring the speed of reactions can be by measuring the temperature change, because if the reaction is exothermic or it is endothermic, because in many of the reactions the heat is released, or in most of the reactions the heat is released, so or in some of the reactions the heat is absorbed. So by measuring the temperature change with the help of thermometer, we can also estimate the speed of reaction. Another method can be by recording the change in visibility of the reaction mixture. If the reaction mixture gets turbid after the reaction, so we will record the change in visibility of the chemical reaction with the help of stopwatch. So these are the different methods to measure the speed of reactions. Now the next important thing in this lecture is that how the different factors they affect the speed of reactions or the rate of reactions. So here, as you can see, that I mentioned different factors which affect the rate of reaction or the speed of reaction. These factors are: number 1, temperature; number 2, pressure; number 3, concentration; number 4, particle size; and number 5, catalyst. All these are the temperature, pressure, concentration, particle size, catalyst. These are the factors which affect the speed of reaction. Now let us understand them one by one, and before explaining these factors which affect the speed of reaction, let me tell you the core idea or the main idea behind these factors which affect the speed of reaction. And this core idea or this main idea is the collision theory of particles, because this collision theory says that if the different reactants, when their particles they collide more, when they collide more frequently, so then when there is greater collision among the particles of the reactant, so then there will be higher will be the speed of reaction. Greater is the collision of the particles of the reactants, higher is the speed of the reaction, and lesser is the collision, so lesser will be the speed of the reaction. This is the main idea. So now let us understand how temperature affects with the help of this collision theory. So when temperature is increased, so generally what happens, that the speed of reaction increases. Why the speed of reaction increases by increasing the temperature? Because when we increase the temperature, the particles, they gain kinetic energy, and the particles of the reactants, when they gain kinetic energy, so then there is greater collision among the reactants, and when there is greater collision among the reactants, so then the speed of reaction will be higher, will increase. Another factor is pressure. When generally we increase the pressure, when we increase the pressure, so the particles, they will come closer. The particles, the atoms or molecules of the reactants, they will come closer, and when they will come closer, so there will be greater collision and greater effective collision among the particles, among the atoms and molecules of the reactants. And when there is greater collision because of the increased pressure and because of the bringing of the particles closer together, so there will be greater collision among the particles, and when there is greater collision, the speed of reaction will increase. Similarly, another factor which affects the speed of reaction is concentration. So, concentration of the reactants, if the concentration of the reactant is higher, if for example this reactant which is represented by black dots and this one is represented by blue dots, for example this is nitrogen and this blue one is hydrogen, and we are forming ammonia. So, by the reaction of nitrogen and hydrogen, suppose Haber process. So, then if the concentration is higher, if the concentration of the nitrogen and hydrogen, if the concentration of the reactants is higher, so there will be greater collision among the reactants. And once again we will say, when there is greater collision among the reactants, so the rate of reaction will increase, it will get higher, the rate of reaction will speed up because of the increase in concentration of the particles. However, the particle size is another factor which affects the speed of reaction, but it we can say is inversely proportional. We can say this one is directly proportional. Temperature increases, rate of reaction increases. Pressure increases, rate of reaction increases. Concentration increases, rate of reaction increases. These three are directly proportional. However, the particle size is inversely proportional. It means that when the particle size is lesser, when it is when the reactant or the, you can say, the chemicals are in powder form, in fine powder form, their particle size is less, so then the rate of reaction will be higher. Why? Because the smaller particles, the fine particles, have greater exposure and they have larger surface area as compared to volume ratio, and when they have larger surface area, so there will be greater collision. Once again there will be greater collision, and when there is higher collision, greater collision, the speed of reaction will increase. And on the other hand, if the particle size is large, so then there is less surface area for the, and less surface will be exposed for the reaction. So then there will be less collision, and when there is lesser collision, the rate of reaction is slow. And the last point is, the last factor which affects the speed of reaction is catalyst. We know that catalysts, they play a very important role in determining the speed of reaction. Catalysts, they speed up the chemical reaction. How? By lowering the activation energy. So when we use catalyst, for example in ammonia Haber process, iron and iron oxide is used as a catalyst. For example, in hydrogenation of hydrogenation process, when we convert the unsaturated hydrocarbons into saturated hydrocarbons, for example in making vegetable ghee or in making margarine from cooking oil, so then hydrogenation process, in this process the nickel is the catalyst. So, in various chemical reactions, the catalysts, they are added, they are used because they increase the speed of reaction by lowering the activation energy. And when the activation energy of a chemical reaction is lowered, is decreased, so that energy barrier is reduced. And when the energy barrier for the chemical reaction is reduced, so then the effective collision among the particles start and it initiates, and in this way the catalyst also play a very important role in speeding up the chemical reaction. So, this is about the speed of reaction. I hope you understood my lecture. Now, at the end, I will request you to please subscribe my channel and share it with other students. Thank you very much.